Artificial intelligence is a broad field of developing machines that can replicate human behavior. This includes problem solving, understanding language, and recognizing patterns. Let's take a look at some of the key milestones in the journey of AI. The dream of creating machines that can mimic human behavior and actions is not new. One of the pivotal milestones in this journey was Unimate, the world's first industrial robot. Unimate was launched on the General Motors assembly line in 1961, where it performed tasks such as welding and handling hot metal parts. In 1989, Deep Thought faced off against the chess champion legendary Garry Kasparov. Deep Thought was a computer designed to play chess. It was initially developed by IBM. This was a draw match. Fast forward to 1997, IBM came up with the supercomputer called Deep Blue. This time the Deep Blue won the match and became the first computer to ever beat a world chess champion in a normal match. This match was a turning point as it showed the potential of AI in strategic thinking. In 2014, Amazon launched Alexa alongside Echo Smart Speaker. Alexa was designed to be a voice control assistant capable of answering questions, playing music, controlling smart home devices, and much more. In 2022, ChatGPT was at the forefront of AI-driven conversation, revolutionizing the way people interacted online. With the advanced natural language processing capabilities, it served as a virtual companion, advisor, and entertainer to millions worldwide. Now that we know what is AI, let us imagine a story which begins with the aim to create a robot for helping a mother in her day-to-day activities in kitchen. For that, we introduce a robot named as a chefbot. Artificial narrow intelligence, subset of artificial intelligence. These systems are designed and trained to perform a specific task or a narrow range of tasks. As a subset of artificial narrow intelligence is often referred as weak AI. You can think of artificial narrow intelligence as a specialist which is really good at one thing but not versatile. Imagine if artificial intelligence is a broad field like science, then consider artificial narrow intelligence as a specialized branch of studies like physics or chemistry. Speech recognition, recommendation system, targeted ads, these are some of the examples that falls under the category of artificial narrow intelligence. These excels within a specific domain but lacks the broader understanding and adaptability of human intelligence. So, while it may not have the versatility of more advanced counterparts, artificial narrow intelligence still plays a crucial role in many everyday applications, providing focused and efficient solution within its designated area of expertise. Moving forward in our story, we decide to specialize our chef pot to master a specific culinary task. It could be mix, bake, or decorate cake. But each skill was learned separately. Remember, because we are dealing with the artificial narrow intelligence, our chef bot cannot do anything outside of what it was taught or programmed to do so. This means it cannot wash the car or it cannot clean the utensils. It can only perform the task that it has specifically learned. Machine learning is a method for enabling computers to learn from the data and improve over time without being explicitly programmed. Here is how it works step by step. The first step is training data. Here we need training data which consists of images of different fruits, for example apple, banana and oranges. Imagine we have such thousands of images of fruits which are labeled correctly with what fruit it is. These images are not just picture to the computer. The computer processes these images as a numerical data. Next is training the algorithm. This involves feeding the data into the system where a programmer writes the code to help computer to understand the pattern and features of each fruit. The result of training the algorithm is an ML model. ML model is the output that has learned to recognize the pattern in the data. It's essentially a trained brain that has absorbed the information and can now make the prediction based on what it has learned. We can then take the new input data which serves as our test data. For example, we might use new images of an apple, banana, and that which model hasn't seen before. This test data is further fed to the ML algorithm. Then the ML algorithm analyzes these new images using the pattern and knowledge that it has acquired during the training phase. Based on the analysis, the ML algorithm makes a prediction and it identifies whether the fruit contains the apple or banana. Then, after making the prediction, we evaluate. If the model correctly identifies the fruit, then it means it has learned accurately. If the desired output is not achieved, then we retrain the model. This involves going back to our training data, tweaking the algorithm, and allowing the model to learn from its mistake. This cycle repeats until the model makes the accurate prediction. And that's how the machine learning works. By continuously learning from the data, improving its prediction, and it becomes more accurate and reliable over time. There are some other types of machine learning patterns and algorithms. As a part of this video and this story, we have covered this one example. Now, moving forward with our chefbot story. Now we want to enhance our chefbot's capability with the machine learning. By studying the countless cake recipes, baking techniques, chefbot learns to improve its performance. It could now adapt to the different cake style based on the data. So now we have learned how the machine learning pattern, algorithm and model works. Now let us implement the same with our story. First step is data collection. In the data collection phase, a large data set of cake recipes is gathered and each recipe is now labeled with the feedback from the human testers from on the final product. For example, the cake has a fine perfect texture or it is too dense. Based on the human feedback, we continuously feedback that data to the chef bot. The next step is training the model. Here, the chefbot supervisory learning algorithm is trained on this data set. The model learns to associate specific ingredient ratios, mixing techniques, and baking times with the quality of the final product based on the human feedback provided. The next is model application. Once trained, the chefbot uses this model to bake the new cake by applying the learned algorithm by applying the learned patterns. Chefbot now can predict and adjust the ingredient and baking condition to achieve the desired results. So this was the first part of this series and I will come up with the next part soon, which will cover deep learning, generative AI, LLM, GPT, GPT-4 and ChatGPT with the analogies. If you like this part, consider liking and subscribing the channel. Thank you.